Bismillahirrahmanirrahim. In this session, we will discuss nuclear energy or fission or fusion processes. But before that, we will see these two questions. We have given two isotopes of carbon, C612 and 614, and give the number of proton, neutron, and nucleons and neutrons. So here in this case we have 6 protons, 6 proton. Here we have nucleons, 12 nucleons. In this second case we have 14 nucleons. Here we have neutrons, 6 neutron, and this is C14 has 8 neutrons. So this is C612 and 614 is isotopes of carbons, and we see that the difference is only the number of neutrons or the nucleons. So the neutrons, and it reflected in terms of nucleons. So in the nucleus, the two isotopes of same element state whether the following numbers are same or different. Number of neutron different, number of, for in case of isotopes as shown here, the number of protons same, number of nucleons different, because here we have a difference, here we have a difference. Now discuss nuclear fission. Nuclear fission, in case of heavy nuclei such as uranium U92-235 and called uranium-235 is the most important. Some atoms of this isotopes decay quite naturally, emit high speed neutrons. So natural decay emits a high speed neutron. If one of these hits the nucleus of a neighboring U235, the nucleus may break. So fission of the nucleus into two nearly equal radioactive nuclei, often barium and krypton. Because this is a stochastic process or a probabilistic process, so the daughters of decays to form different kinds of daughters, and the production of the 2 or 3 more neutrons. So in every fission, 2 fission daughters produce, and the 2 to 5 number of neutrons usually released, mostly 2 to 3 in average. The energy release is large and appear mostly as the kinetic energy of the fission fragments. In terms of fission, a large amount of energy is released, and these fly parts at a greater speed, colliding with the surrounding atoms and raising their average kinetic energy and their temperature. The fission fragments are called daughter nuclei, and the original uranium is called a parent nucleus. The other isotopes can undergo fission, such as plutonium-239, that can sustain a chain reaction, which are from nuclear fuse. If the fission neutron is split other uranium-235 nuclei, a chain reaction is set up like this. So if neutron strikes, it produces fission fragments, and then the other neutrons release and it strike with the other U235s, and results this daughter products and neutrons. In this way, a chain reaction is started. In practice, some fission neutrons are lost by escaping the surface of the radium. So these neutrons, if these neutrons release or it not strikes, then this sustained reaction cannot be, this chain reaction cannot be sustained. So in order to maintain a sustained chain reaction, its geometry should be proper. It should have a proper geometry. So the ratio of these causing fission to these escape increase as the mass of uranium-235 increases. This must exceed a certain critical value to sustain the chain reaction and a geometry as well. So this is a nuclear reactor. Here we have control rods that's control the reactivity process, because this control rod absorbs the neutrons. So, and this graphite core, and here we have pumping process and this hot gases process through, and here cold water enters to produce steam, and that steam works on turbines to roll it, and coupled generators produce electricity. So the chain reaction occurs at a steady state, which is controlled by inserting or withdrawing the neutron absorbing control rod. This control rod basically absorbs the neutron, and neutron that release is absorbed by this control rods, absorbers. So the graphite core is called the moderator. This graphite core is called moderator. It thermalizes the neutron, the high-speed neutron, and that the chance of interaction of neutron with the uranium increases as a result of this moderation. Carbon dioxide gas is pumped through the core as a coolant, and the coolant is used as a carbon dioxide here in this graphite type reactor. And different other kinds of reactors, they have a different coolant. Somewhere in a liquid water system, pressurized water reactors, and other type of reactors, boiling water reactors. So the reactive fission fragments must be removed periodically if the nuclear fission is to be used efficiently. And in an atomic bomb, an increasingly uncontrolled chain reaction occurs. This chain reaction, if this chain reaction becomes uncontrolled, then it becomes an atomic bomb. When two pieces of this together exceeds the critical mass. So if uncontrolled chain reaction started, then it becomes a nuclear bomb, atomic bomb. Under what condition does a fission reaction occurs? Light nuclei joins together to make heavier ones. In a fusion process, fusion reactions, fuse, the two light nuclei becomes fuse each other to make a heavy one. This can also lead to the release of energy. Such fusion reaction has been achieved in hydrogen bombs. Hydrogen bomb fusion reaction occurs. Fusion can only occur if a reacting nuclei have enough energy to overcome their mutual electrostatic repulsion. Suppose two hydrogen atoms have to overcome their electrostatic repulsion to recombine, and that requires a lot of energy to sustain this kind of reaction. So why a fission reaction? Why is a fusion reaction self-sustaining? This can happen if they are raised to a very high temperature. If the temperature is very high, so that they collide at a very high speed, if fusion occurs, the energy release is enough to keep the reaction going. Since heat is required, it is called thermonuclear fusion. So heat is required, that is why this nuclear fusion reaction is called thermonuclear fusion. Do fusion or fission or fusion reaction occurs in the reactor of a nuclear power station? Only fission reaction occurs in the reactor of the nuclear power station, and fusion is not possible because it generates a very high amount of energy and requires to develop or to maintain this fusion reaction. A lot of heat is required, and this occurs, fusion process only occurs in sun. The source of energy, sun energy, is nuclear fusion. The temperature in the sun is high enough for the conversion of hydrogen into helium to occur in a sequence of thermonuclear fusion reaction known as hydrogen burning sequence. So this is hydrogen burning sequence that occurs in the sun and where a nuclear fusion reaction occurs spontaneously. And this is exam style questions, and here define a proton Z and nucleon number A, proton number Z and nucleon number A. Explain the meaning of a term isotopes. Isotopes of an element are the atom that have the same number of proton but different number of neutrons. That is, their proton numbers are the same but their nucleon numbers are different, and elements may have more than one isotopes. And isotopes of helium can be written in nuclear notation as this. Describe how an atom of this differs from the this is helium 2He3, 2He4, here A is 4, here A is 3, Z is 2, Z is 2, and the number of neutron is here 1, and here we have 2. An atom of calcium can be written in nuclear notation as 2040 Ca. So 2040 Ca, A is 40, Z is 20. In a neutron, the neutral atom of calcium state the number of proton. So proton is basically 20, nucleon is 40, neutron is 20, electron is 20. Why a calcium atom loses an electron? It becomes an ion. State whether the ion is negatively or positively charged. Whenever electron release, a positive charge gains. If electron gains, it becomes negatively charged. So in case of electron release, it becomes a positively charged. Describe the importance of Giegler-Marson experiment on the scattering of alpha particle by thin metal film to understanding the structure of the atom. Giger and Marsden experiment results confirmed Rutherford formula and supported the view of an atom is mostly empty space, because in this experiments it passes most of the in most of the cases this was passive, somewhere it deflected and very few reflected. So this was discussed earlier. And state the charge on proton, neutron and helium nucleus. Proton is positive, neutron is unchanged, helium nucleons are positive because of the difference, because this is uncharged, this is positive, so neutron and proton becomes positive charge because this is uncharged. Explain what is mean by nuclear fission. The heavy metal or uranium is a mixture of this and is more important. The atoms, these isotopes decay quite naturally, emitting high-speed neutron, and fission fragments are called daughter nuclei, original uranium called parent nuclei. Other isotopes undergoes fission such as plutonium, and this is nuclear fission chain reaction as discussed. And for to maintain a chain reaction, sustainable chain reaction, its critical value, certain critical value has to be ensured, or it has to be maintained, must be there. Nuclear fusion, heavy and light nuclei makes heavy one. Hydrogen bomb is an example of nuclear fission. It happens in sun, and this is all discussed. And outline the process that occurs in a nuclear reactor. Nuclear reactor, here heat generated, and this of coolant, it transfer heat to this secondary cycle, and from there we insert some cold water and produce the steam, and that steams roll the turbine, and electrical energy produced. Carbon dioxide gas is a coolant, heat exchanger. An atomic bomb and increasingly uncontrolled chain reaction occur when two pieces of uranium-235 come together and exceeds the critical mass. So this is all from section 5.1 of nuclear model of the atoms. In the next topic, in section 5.2, we will discuss radioactive